Hey everybody, how are you going? I You are live. Turns out that I hit the go live button like slightly without realizing it. So, hi, it's nice to see you. I hope that you are doing well. If you're watching the recording, I thoroughly recommend that you subscribe to get notified of future calls like this. And I am super excited for what we have on the agenda today. Hi everybody, it's awesome to see you. Sorry, I just stood there doing nothing. Go grab a cup of coffee or a cup of tea or some water. Put on some music. I'm not going to put on background music onto this one because I always feel like people can choose their own vibe, you know? Let's get started. Okay, so one of the things that I'd like to encourage you to do is join the Discord server. Here is a QR code. You'll see this pop up a few times. It's a really wonderful community. We've got about well over 1,000 people in there now, and it's a very supportive place for anyone who's kind of building themselves up in technology, and in particular with a little angle on Rust. So what are we going to be talking about today? One of the things is I'm going to be trying to do a code review. In fact, I'm going to be trying to code review 3 crates. And I really want to call this more of like a code showcase rather than a code review, but code review is the word that everybody uses. So that's the word that I'll use. I also want to be demoing a couple of projects as well, specifically 2 crates that have been put forward as Crate of the Week by the Rust community. And then I've got a Q&A section where I go through questions that have already been listed in the Discord server that I mentioned before and try and answer them. At least provide a little bit of insight. Okay. Code review time. Really code showcase though, right? Okay. So I got my little laser pointer. And I was going to bring up my editor, but actually I need to tell you about which crates we're talking about. The first one is this thing called Strum. And Strum is a small library for adding custom derives to enums. Now, what is that? Well, it turns out that... well, let's go have a look. It's a relatively old crate. It's a couple of years old. And a custom derive is a derive macro on an enum. So for example, well, that's what this project offers. So if I go to my play Rust, and then if I wanted to create an enum, let's call it size, and I've got small, medium, large. One of the things that I may wish to do is go and, we can sort of derive, debug, but what would be nice is to be able to derive display. That's what this Strum thing does. It provides a bunch of other pieces of functionality as well, like you can add messages, you can... it's all documented there. So let's go dig into the code. Audio is clipping. Okay, I'll turn the volume down. How is that? Is it still too loud? Thanks for the notification, by the way, James. Okay, let's go into Strum. So Strum is best explained by its tests. The tests that it has available are pretty extensive. It has two types of tests. We are looking at the integration tests. And so, for example, I wanted to create an enum from a string. And so I wanted to automatically derive enum string. And so we've got a color here that has multiple different types of color names, but also some relatively advanced functionality inside the enum. Like we've got a struct being provided in this hue and a bunch of other bits and pieces. And the tests all work. So let's go and see. That is, I can define color red, and the test goes and checks to see whether or not I can take the so the tests have an A section, which is the enum itself. I'll just increase the size so it's a little bit easier to read. So the A on the left is some type T, and then on the right I've got the string that I want to be able to convert between, and then the test calls from stir from this one into the left side. So it kind of swaps them around internally. Now then unwraps, because presumably it's saying that if the tests panic, that's a fail. And that's actually how tests discovery works in Rust anyway. So in Rust, if a test fails, it means that the test itself has panicked. So let's go into the implementation. Oh. How is everyone, by the way? I hope that you're doing well. I'll give myself some space. And so here is Strum. What we're looking for is our library. And you'll notice that this crate is actually, it has a front end, the Strum thing, and a sort of a back end crate, which is this macros thing. One of the things that I noticed when I first looked over this code is that that this made sense internally, and one of the questions that we are going to see is like, how do I break things up? But what you are doing here is essentially adding some privacy to yourself about how everything is implemented. So it's a little bit of indirection. We're looking for this custom derived macro, but it turns out that it's not in Strum itself. It's in Strum macros. And then I've got the source, and here's our macros. And we've got from repr, and what we're looking for is the from stir. So there's from string. And I could probably search for it, but why not? Just kind of go and look for it. The code is like all of this code seems quite workable to me, but I am just going to go and try if I can see if I can search for it. So we want from stir, search in the repository, and oh, I see. So it's in a helpers crate. Oh no, this is an implementation of the from. Okay, so this is a little bit less useful than I would like. Okay, let's go back to our test. Tests from stir, and Ah, okay, right. So the actual macro is called enum string. That's what the derive is called. So I'm getting confused because the trait from stir is actually part of the standard library. Now, I've got lots of tests. Serialize, more tests, lots and lots and lots of tests. But very, there we go. Struct macros from string. So let's go into the code itself. Okay, proc macro derive enum string, and then we are already into some very advanced Rust code. So the procedural macro sort of internals rely on some machinery that's pretty advanced. We need to be able to access a token string, and our macro returns the same thing that has been transformed in some way. And debug print generated. What is so we tox would be a shorthand for tokens. The AST is the abstract syntax tree. You get a sense from the code that it's quite good, or at least that's my impression. But I still haven't found the implementation of this enum string thing, which will be in macros somewhere. Source, macros, strings, from string as refstir display to string. I probably should carry on, but you can see one of the things that I wanted to bring out was how they've how the authors have structured this code. So the it's quite fine-grained. That is, each derived macro has its own file, and where there are related macros, in this case, these all relate to strings, they exist within inside their own module. By the way, I should point out that no one has asked. Well, sorry, I haven't gone and checked with anybody if they're okay with me inspecting their code. So hopefully, hopefully no one's going to get embarrassed that I'm having difficulty finding the implementation. One of the neat things was that you can actually automatically implement display. That was what I wanted to show off. Okay, so the way that it works is that we take the AST, so this thing that has been sort of pulled apart by the syn crate, which is or by the proc macro. These two, oh gosh, we've got an abstract syntax tree that is of type derive input provided by the syn crate, and we need to return back a token string. And so we get the identifier, which is the variance name, and we now need to derive a new trait called display. And we kind of go through a bunch of the variants and check whether or not this is something that is valid. And you can see here that you can define a preferred style with inside the macro, and we have these quote syntax, and then a little bit of extra validation, or at least special casing, or Yeah, we do have a special case here. It's like if the number of AST is for some reason less, I'm actually not entirely sure what arms is, but if we've got a check here and then we panic. We panic during compilation, so that's not particularly nice, but presumably that's the way to... Oh, no. Actually, it's not. We quote a pattern, which is the underscore. So this is anything else. If somehow in the code that it calls, format is called on some disabled variant. So you might think, that's strange. So essentially what it's saying is if your future code calls something that is no longer valid, then this introduces a panic when you try to print it to the screen. I feel like that is the kind of thing that should be documented. Like essentially you're kind of adding a new bomb in someone's code. Arguably it's the right thing to do. You can't return an extra value. Like display does not panic. Sorry, display does not implement result. The only thing that you can do is panic. Potentially though, if you're just printing something to the screen, you could do some thing with that. But surely they've thought about it. Anyway, we now go and implement display for our name. And we've also got a where clause as well. And all we need to do is match on self and then match on all of the arms that we have just created. Now I know what the arms are. So the arms are a vector of all of the patterns that we are creating. And okay, so that's cool. So you can see how the macro is being built up. And the rest of the code is pretty similar to this. We start with our input, and then we go and inspect it, check that it's correct, or matches what we expect, and then build up our new AST and return it. Well, it's formally a token string rather than AST. Okay, cool. Well, hopefully that's been fun. People are still watching this stream. I've got a counter on my side, which is saying that there are some people actually still watching. So, power to you. I now wanted to talk about Rust CSV, which is a parser for Rust with Serde support. And the typical thing would be to go and look at the the main branch. But I want to do something kind of fun, which is to look at some of the old code. So the CSV crate is sort of one of the first that I ever looked at, or not internally, or it was one of the first crates that I ever used in Rust. And I'm now looking at some code that is 5 years old. It was 1.0 was a big deal, and it provided CSV parsing that was just unmatched in terms of performance, but also memory usage as well. It was just ridiculously good. So it's in some sense pretty easy to reason about. It's, quote, just a parser. It can take some messy CSV, or potentially not messy CSV. And then go and turn it into real working Rust. And there's a whole bunch of functionality within it as well, which is quite cool. The CSV crate is broken into a couple of subcrates. So it has this core thing, which we'll look at shortly, and an index, which provides indexing structures so that the Rust types themselves can very efficiently point back to the parts of the file that are being referred to, so that you can support a kind of like an in-memory database, or use the CSV file sort of as a data store. Now, one of the fun things about this crate is that it's really complicated. So there's a lot of computer science that's going on in here, and there's this great message that be advised, it starts. This may just be one of the more complicated CSV parsers you'll ever come across. This implementation never allocates. So what that means is there'll never be a call to alloc, or there'll never be a request for extra memory, and consists of both a functional NFA, so what the heck's that, and a DFA parser. So it's not just one parser, it's like a hybrid of two parsers, and immediately the documentation says that it's basically saying if you don't know what NFA and DFA means, you're not going to have a chance in this code base. It's too hard. So NFA stands for non-deterministic finite automaton, or automata probably in the plural, and the DFA is a deterministic one. DFA does most of the work, but they work together. I think that NFA actually provides more functionality, and I like that Burnt Sushi, states, the code is too good. Like, it's too clever. And like, what? Like, let's talk about how ridiculous this thing is. So here's a convention in Rust. So 2 slashes is mean that this comment is for people who are reading the source code, whereas 3 slashes is documentation for end users that will be rendered as HTML. So it's really well documented and describes a lot of the internal details, and the reader here is a type that can read a CSV file within the with all its messy internals. CSV is like sort of an underspecified file format, and so every parser kind of makes its own trade-offs. The default trait provides the ability for you to just ask for a blank reader that starts with all its defaults initialized to some valid value. So for example, we start on line 1, not line 0. Doesn't make sense for a file format and to start in line 0. And we've got default quotes and delimiters, for example. The other thing to note is that this crate is a good demonstration of what we call the builder pattern, whereby Rust, the builder pattern is a sort of a kind of constructor, or really a modifier. It takes some type that has been initialized and modifies it according to method calls to get around. Actually, that's not specific, like strictly true, because builders are often their own types, and then they construct something that is internally. Oh gosh, there. Is internal. And so what I mean by that is, well, let's go. So the build, why is the builder pattern really common in Rust? That's partially because Rust does not support named arguments. And so when I use these builders, I can provide a method call that works as if it is being used as a named argument. It will mutate the internal reader itself, all of these tiny little calls, and then return itself. If the convention is that these methods just do one very small thing and then return themselves, allowing the builder to be chained together. And then there's a final call that returns the self itself. Like in this case, it's returning sort of the inner type. So that's all conventional. And the abstract syntax tree is very similar in a sense. It is very conventional with what we expect. That is, it's an enum for all of the different field names. And this thing keeps popping up. I might have to keep it open. And then we also see the use of extra comments on all of the variants. So Andrew Gallant, otherwise known as Burnt Sushi, has done a really good job at making sure that people that are using this code really understand what is happening. It's one of the things that I really appreciate about the software that he writes, is that it's extremely well documented. Let's go and try and see if we can find any kind of fun tricks. Now, again, this is really difficult Rust. And one of the things, for example, that he's doing is using the internal. He's using these numbers to enable the inside some state, such that the states can be sorted, and that has the NFA states are able to be sorted, and he's using the ability to provide a specific number yourself or a specific internal representation to be able to make sure that the sorted order is exactly what he would like it to be. So for example, the start of the record is always at the start once you sort, because it's internalized as 0, and the end is always last. So it's kind of a cool way to use an enum for the type safety, but actually to be able to sort of have like a sorted, like all of your tokens in order, and as well. The code is difficult. We're only at line 745 of 2,000 lines of code in this just the reader section, and but we have found a couple of kind of fun, nice bits and pieces of Rust, which is quite cool. And there is a very nice demonstration of how unit testing works within Rust. Again, so one of the things that we can see here is that we're bringing in the type that we are interested in. In fact, the reason why he's doing this is because it's an enum, and he doesn't want to have to bring in, type out the whole thing later on. Creating a reader from and this is a sort of a buffer. It's just 10 bytes long. And saying that if you read this /foo thing, this is what you expect. So I assume that it's, I see, test that we can reset the parser. So all of these tests are documented with what they do. Test that empty output buffers don't wreak havoc. He's testing the functionality of the reader itself, this reader type, not its ability, presumably, of being able to deal with all of the messy CSV stuff. Oh, no, here we go. Here's an example of escaped quotes that appear within the stream. So you've got all of his edge cases are documented, but it's really interesting to me that he seems to hate memory allocation. Even his tests are only fixed sized buffers. He's like, oh look, I never want to impose a memory allocation on my users, which is really hard to achieve. And I'm kind of blown away that he has been able to get it so performant. Like the even the tests are not even allowed to use strings. That's crazy. A test, yeah, it's astonishing to me. Okay, cool. We have got. Let's move on to the next crate. SVAL or SVAL is a serialization framework, kind of an alternative to the elephant in the room, Serde. Now, I have to move my face away. There we go. So now you can see where to go if you wanted to check it out yourself. You're very welcome to. So this SVAL thing is a what is it? It describes itself as a serialization-only framework for Rust. So that we'll start at the end and work backwards. That means that it can only take a Rust type and create a string out of it. So it can only serialize. And that term serialize means that it takes potentially some nested data or hierarchical data or relational data and serializes it into a linear serial of bytes. I'll bring my face back down here. I always used to find that word really odd. The reason why it's really cool, it should be much faster than Serde. Serde is extremely general purpose and suffers from that from a performance point of view, even though it is the crate that almost everybody uses. There are some things that are a bit. There are it's actually only one space or like one point in the whole design space.